Next type of graph to look at, absolute value. What does that do to our function? Let's go look at several different variations of what we could get. Y equals the absolute value of function x. Symmetry in the x-axis. Well, the final picture is not actually symmetric, but it involves reflecting in the x-axis. So whatever bit is below gets reflected above. So here's our random curve. If I was to draw this one, below basically disappears and is reflected above. The absolute value of function x. And that's probably, at this stage, the main one we've seen so far. And that's how we created, you remember y equals absolute value of x and all those linear functions. But what if I put the absolute value just on the x? So y equals function absolute value x. Again, it involves symmetry, this time in the y-axis. So what happens? Well, there's the description of it. Let's look at it in a picture. The left-hand side now disappears, and the right-hand side reflects over. So the negative goes away, and the positive reflects through the axis. If I put the absolute value on the y instead, same sort of thing happens, but now it's with the y values. So the negative goes away, the positive reflects. That's absolute value of y equals function x. Okay, what about this one? If I do absolute value to both of them, we're going to end up with both of these ideas. Negatives go away. That basically means I'm only left with the first quadrant. That's the only quadrant that has everything being positive. And that gets reflected into all four quadrants. All that goes away, and that gets reflected into all four quadrants. So that's if both of them have an absolute value around them. Y equals the absolute value of function absolute value x. What happens here? Okay, well, we saw that was function absolute value x. We combine that with the first one we saw, absolute value of function x, whatever's below, reflected above. One more, let's try this one. Absolute value of y equals absolute value of function x. Okay, so there's function x. Well, we did y equals absolute value of function x, and it ended up being that. If I now go absolute value of y, we said, well, whatever's negative disappears. Well, there is nothing negative here, it's gone. And then reflects over. We get that very interesting graph. And there's probably other combinations we could play with there, but let's now have a look at the square root graphs. We've seen some of those. We've seen the semicircle, which was square root of r squared minus x squared. And we've seen half a parabola, y equals square root of x. But what about square root of other things? What do we do? Well, here's two key things. We know the square root will only be defined if that function is greater than or equal to 0. We know that to be true. And we also know it's got to be positive, because we're saying find the positive square roots. Okay, here's random graph then. Well, that means this bit below doesn't exist anymore, and this bit below doesn't exist anymore. It's no longer in the domain. Stationary points will still end up being stationary points. Yes, the y value might change because you're finding the square root of the y value, but on those x values. So I know then that up here, that's still going to be a stationary point, but I'm finding the square root of a number bigger than 1. So it's going to stay bigger than 1, but it'll be a smaller number. So it comes down a bit. Horizontal and oblique asymptotes, they may well change, because again, we're finding the square root of everything about this function. So we're finding the square root of the asymptote as well. The vertical asymptote, that stays there. Horizontal, at this stage, we have the original one, which is less than 1. Find the square root of a number that's less than 1, it becomes bigger. It's not going to go bigger than 1, but it'll be bigger than its original value. So I'll put it about there. Now, when we're drawing the graph, similar to what we saw with square, but now it's going to be the other way around because we're finding the square root. So if the original function is bigger than 1, then the new curve that I'm going to draw is going to be below the old curve. And if that number is less than 1, then the new curve that I draw will be above the old curve. 1 therefore again becomes a key value, because square root of 1 is 1. So we'll plot those ones in. The x-intercepts. Now this is where we need to think about this very carefully. Let's look at this. Y equals x to the power of a on b. I've drawn two graphs there. X to the power of a third and x to the power of 2/3. Both of those powers are less than 1. What is similar about those two curves? And it's this. They're both concave down in the first quadrant, and you have a vertical tangent. Notice the vertical tangent. Now, on the first one, it inflects and comes back through. At 0, at that point of inflection, you get a vertical tangent, if you were to draw it in. Over here, x to the 2/3, it's also a vertical tangent. See, both curves would be coming in and end up with what we call a cusp. So we get a vertical tangent there. And that will always happen. We'll always get a concave down curve in that first quadrant if the power is less than 1. That will always happen. 3 on 3 is obviously our straight line. But let's have a look at the comparison now when we start getting the powers that are bigger than 1 and the concavity flips. In the first quadrant, it's now concave up. Each of those are concave up, and the tangent now is a horizontal tangent rather than a vertical tangent. Here's several to illustrate that as well. So if the power was x on 4, we know the graph, it's got that U shape, but it's going to be flatter at the base than a parabola, steeper at the sides a bit. The square root, well, square root of x to the power of 4 is x squared. So it's our parabola, but it's bigger than 1, so look, yes, it's concave up in that first quadrant. Another thing they might ask us to draw, instead of drawing y equals the square root of function x, they might say, hey, draw y squared equals function x. Now, if that's the case, it's not just y equals the square root of function x, but it's y equals plus or minus. And so you'll now get a reflection in the x-axis. The picture will go over. X cubed, there it is, our cubic. We find the square root of that. The power then becomes 3 on 2. That's bigger than 1. So we're going to get a concave up curve. We'll have a horizontal tangent. And you can't find the square root of a negative number, so it disappears on the left-hand side. And if it was y squared equals function x, we get the reflection in the axis. Y equals x squared, our original parabola. Well, square root of x squared is x. We get our absolute value shape actually, because it's coming in and, well, you can't really say it's got a vertical tangent or horizontal tangent for that one because we've got a straight line. It's just a sharp point. And if you did y squared equals function x, you get an x shape for that one. Okay, 5/3. That would be the graph of x power of 5/3. If I find the square root of that, I'm going to get 5 on 6, which is a number less than 1. So now the curve changes to being concave down. I have a vertical tangent. It disappears, and you can't find the square root of the negative number, so it disappears there. Reflect it, we get that shape. 4/3, then that becomes 2/3 when we find the square root, which is less than 1. So we get a concave down shape. This one does, because that's fine, it's positive. I can find the square root of a positive number, so we have that reflection. And a vertical tangent. So that's the idea when we're finding square roots. Have a look at the size of the power, what it's going to become. Is it going to be bigger than 1? Is it going to be less than 1? Then you know whether the curve's going to be concave up or the curve's going to be concave down, whether you've got a vertical tangent, whether you've got a horizontal tangent. Alright, so back to our random one. Well, I don't actually know because it's a random curve, but it's a fair bet that it's just a linear one because it's cutting through like a straight line. So the actual factor would be probably to the power of 1. That's what I'm going to assume for the sake of my picture. Well, if that's the case, finding the square root of that, I would get power of a half, less than 1. I know I'm going to end up with a vertical tangent, and it'll be, well, it'll be a bit like the semicircle, the half a parabola. It's going to be concave down, I guess is what I'm saying. Okay, so at those points, I know I'm going to have, it's going to round like the circle, and let's try and draw that in. Yeah, very, very dodgy. Got rough. I might have exaggerated my vertical tangent a little bit over here, but yeah, I was trying to show, yes, that would be a vertical tangent. You get that rounding. So there's y equals the square root of function x. If I wanted y squared instead, then I would reflect it. And that now really highlights how dodgy that one was. But anyway, okay. So 5e, let's play around with these sorts of graphs.